This is the second part of the chapter, energetic. Here I'll explain Hesss Law and the enthalpy change calculation. The main points are here: explanation of Hesss Law. Here I'll give this very simple explanation so that you can understand. And another one, application, how we can calculate enthalpy change using Hesss Law. First, the statement of Hesss Law. The enthalpy change in a chemical reaction is independent of the rate of the reaction. Maybe it is difficult to you. I'm giving you easier than this one. Let's see. Enthalpy change of a reaction does not depend on the steps of the chemical reaction. Let's see easier than this one. If a chemical reaction occurs in one step, two steps, three steps, or many more steps, total enthalpy change will be the same. Let's see the example. Reactant A converts to product B. Here the enthalpy change is delta H, just one step. I'm showing you for two steps. Delta H 1, 2 intermediate, and then intermediate C to the final product B, delta H 2. So total enthalpy change for this second stage, delta H 1 plus delta H 2. So according to the Hesss law, we can write delta H equal to delta H 1 plus delta H 2. To make it easy, I'll giving you many examples. Example 1. Here the methanol is made from carbon monoxide and hydrogen. For this calculation, enthalpy change calculation, I have to calculate delta H. For this one, bond energies are given. So using the bond energy of carbon, oxygen, hydrogen. So here we are making atom, gaseous atom from carbon monoxide and hydrogen gas. So bond energies are here 1940. You have to remember, you have to use here carbon, oxygen, triple bond for carbon monoxide. I think you know this one. And the bond energy of carbon, hydrogen, carbon, oxygen, and oxygen, hydrogen, total amount delta is 2050. Now I can apply the Hesss law. Using the Hesss law, delta H plus delta H2 is equal to delta H1. So from here, that delta H equal to negative 101 kilojoule per mole. This is the amount of enthalpy change for this reaction. I'm giving you another example, that is enthalpy change for a decomposition reaction. Copper 90 decomposed to copper oxide, nitrogen dioxide, and oxygen. In this case, the enthalpy change of formation are given. So I'm writing the equation again. Here delta H you have to calculate. So since formation is given, so we can make copper nitrate from its elements copper, nitrogen, and oxygen. So here delta H 1, 2 into negative 3O2, and formation of copper oxide, nitrogen dioxide, we can make negative 180.8. Here the formation of oxygen is 0. So applying the Hesss law, we can write delta H 1 plus delta H is equal to delta H 2. The final answer is positive 242. So for these two examples, if you have seen, for these two examples, I have drawn the enthalpy cycle diagram. If you have any question for the cycle diagram, you can see the description of this video. I have given many clues there. Then another example for you. This is the problem here, given enthalpy change of combustion, but we have to calculate enthalpy change of formation. So this is the formation of methane from carbon and hydrogen. From this one, enthalpy change of formation is given. So we are data given is combustion. So we are making carbon dioxide from carbon and water from hydrogen. So here the enthalpy change is negative 966, and for the methane the combustion enthalpy is negative 891. So applying Hesss law, in this case we get delta SF plus negative 891 is equal to negative 966. So from here delta SF is equal to 75 kilojoule per mole. I'm giving you another example for enthalpy change calculation for a solution, but there is no Hesss law here. So for this case, 25 gram of copper to sulfate dissolved in 100 cm3 water and temperature changes to 2.9. For this case, first I want to calculate the heat change. Q is equal to mc del theta. Here m is here 100 cm3 water, and c is the specific heat capacity 4.2, and the temperature change 2.9. So here the heat change is 1.218 kilojoule, and the mole is equal to mass divided by mr. Mass is 25 and mr is 249.7 for the copper to sulfate. So for this one, mole is equal to 0.18. So enthalpy change is equal to Q divided by mole, and getting the enthalpy change negative 2.18 kilojoule. If you have any specific question about this topic, you can write in the comment below. I think you'll get the correct answer. If you get very little benefit from this video, please subscribe this channel and share with your friends. Thank you very much for watching this video.